Hey everyone, a very warm welcome back to the channel. Today we have a very good and very high quality question from the chapter of AOD, monotonicity and maximum minima. The question is asking us to minimize the value of the function 4 power cos x plus 4 power sin x, where x belongs from 0 to pi by 4. Maximum time allotted for this question would be 15 minutes. Ideally, you should try to do it within 7 minutes. So you can pause the video, give the question a try, and then return back to have a look at the correct solution. So I hope you all have tried it out. Now the answer to this question would be 5, and let us also see how to solve it. So concepts and formulas used are very simple and basic. Derivative greater than 0 implies increasing nature of function. Derivative less than 0 means decreasing nature of the function. And method of critical points and sign scheme also we should know. So let us now assume that f of x is equal to 4 power cos x plus 4 power sin x. Then clearly the derivative comes out to be this quantity. Now to find critical points, we obviously need to solve f prime x equal to 0. And on rearranging this, we are going to get 4 power sin x upon sin x is equal to 4 power cos x upon cos x, which we are calling as the equation number 1. So this gives us a strong indication to assume the function g of t as 4 power t by t, because obviously then this becomes g of sin x, and this becomes g of cos x. So that's the reason why we are taking this. So derivative then g prime t comes out to be this quantity. But since sin x belongs from 0 to 1 by root 2, and cos x obviously belongs from 1 by root 2 to 1, because x belongs from 0 to pi by 4. So a graph basically looks of gt, it looks like this. Clearly 1 by ln 4 would be a point of minima by easily observing that this is positive and making the sign scheme of this quantity. And then 1 by root 2 is here, and 1 would be here. So the thing is that through this graph, we have neither been able to show that gt is a monotonic function, nor have we been able to find an easy way to figure out a solution to the equation g of sin x equal to g of cos x. The reason is, let's say this is, here we have sin x value, okay, and this is g of sin x, and let's say cosine x will be somewhere between 1 by root 2 to 1. Let's say it is here. So this would be cos x, and this would be g of cos x. So clearly these values can be equal also through this graph. So, and but we don't have any easy way to find the x at which this occurs. So this approach fails, and thus we need a different approach. So we will rewrite the equation number 1 as, this is the equation number 1. So this we'll rewrite it as in this form, okay, and then we will take logarithm, which we are calling as equation number 2. And now we are not considering the closed interval, we are only considering the open interval. That's why we have been able to divide, take logarithm and everything. Now let us call h of x is equal to this function minus this function, okay. So that's what we are calling as h of x. H prime x we can find very easily. We can write it in terms of sin x and cos x, and taking LCM, this is what it becomes. Now let us consider this function alone to be p of x. So this is the function. The derivative p prime x comes out to be this function, and on simplifying, this is what it becomes. So cos x minus sin x comes out common, and inside we are left with this quantity, which is obviously greater than 0 for all x in the open interval 0 to pi by 4, because cosine is greater than sin x in this interval, and this is obviously positive. So p of x is an increasing function in this interval. Now numerator h of h prime x, let us call it n of x, is obviously, it was equal to this. So it will also obviously be increasing, because n prime x, you can see that it will come out to be ln 4 into p prime x. And this is positive. P prime already we have proved positive. So n prime x will be positive. So it is an increasing function, obviously. But n of pi by 4 comes out to be this quantity, which is obviously less than 0, since we know ln 2 is approximately 0.693, root 2 is approximately 1.414. So easily you can observe this will be a negative quantity. But since n of x was an increasing function, so in this interval n of x would have to be less than n of pi by 4, and which is less than 0, as we have already proved. So n of x would be less than 0. And since n of x, the numerator, is less than 0, h prime x would also be less than 0 because denominator of h prime x was sin x cos x, which is anyway positive for any x in this interval. Sine is also positive in this acute because x is acute, and cos is also positive. So the entire thing is positive. So the numerator will only decide the sign of h prime x because denominator is anyway positive. So h of x is a decreasing function, which means that h of x would be greater than h of pi by 4. Now you might say, but why are we taking pi by 4? We were only talking about the open interval. So no problem. Instead of this, you could have also written limit x tends to pi by 4 minus h of x, and that would also have anyway come out to be 0. So it is still, it really doesn't matter, you know. So h of x is greater than 0 is what we are able to observe. So what we are actually saying is that for the open interval, certainly h of x is always strictly greater than 0. Okay, for open interval, it is strictly greater than 0. So the equation 2 will have no solution in the open interval. What was the equation number 2? The equation number 2 was basically this. Okay, so in the open interval, it certainly does not have any solution. So this does not have any solution. So f prime x equal to 0 does not have any solution in the open interval. Which we are saying 0 to pi by 4. Now what we are saying is that since there is no critical, so there is no critical point of f of x in the interval 0 to pi by 4, because f prime x equal to 0 does not have any solution, right? And basically critical points are also, you know, they also come because of f not being defined or f prime not existing. You know, so these are also the reasons, or it is not continuous, not differentiable, something like that. But obviously in the given interval, f is continuous, differentiable everywhere. So the only way critical points could have, you know, we could have gotten critical points was through derivative being equal to 0. And clearly there are no critical points in the open interval. Now, how are we going to, so basically from 0 to pi by 4, if we don't have any critical points, so f prime 0 plus, if you find, it comes out to be greater than 0. So f prime x would be greater than 0 throughout the interval. That is the sign scheme method, right? Between any two critical points, we basically find the value of the function at any point. And if it is positive, then it remains positive throughout this interval between the two critical points. And if it is negative, then it remains negative throughout. That is basically the sign scheme method, right? So since at 0 plus it is a positive quantity, we can easily observe. Okay, just put in 0 plus here in the f prime expression, and you will see that this becomes 0, this becomes 1, and 1 into ln 4 is greater than 0. So basically that's what we have done. Now what we are saying after that is that, so for all x in this interval, f prime x will continue to remain positive. And the reason is also by sign scheme method, of course, you can say. Another reason is that let us assume that sometime it does become 0 less than 0, negative. But then that would imply by IVT for intermediate value theorem for continuous function that it must have been 0 somewhere, but we have already proven that it has no critical point, so no root in between this. So that's the logic behind this sign scheme method as well. So we can say that f prime x would be greater than or equal to 0 for all x in the closed interval 0 to pi by 4, because at pi by 4, if we find the derivative, it can also come out to be equal to 0, as we can see. But nonetheless, doesn't matter, even if it is greater than equal to 0, it is still going to be an increasing function in this particular x. In fact, it is going to be a strictly increasing function, even though I haven't written it down here, but obviously, because the thing is that from 0 to pi by 4, the f prime x was strictly greater than 0, right? Only at pi by 4 does it become horizontal. So clearly, it is going to be a strictly increasing function, but it wasn't required here. So even with the greater than equal to, we can get the job done. So f of x is an increasing function in this interval, in the closed interval 0 to pi by 4. And that's why we can say that f of x minimum value would occur at x equal to 0, which is 5. So 5 would be our final answer. Now, a very big mistake that many students often do is that equation 1, they write it as this way. In this form they are able to write. Then in 0 to pi by 4, they observe that both these functions are increasing as well as concave up. So, and also at x equal to pi by 4, both functions have equal value 1. So they think that their graphs must look like this, the way I have drawn here. And so no critical points would be there, and then directly they would be able to do it. But this is a wrong method. And what is the mistake? The graphs can also look like this. In this case also, they are both increasing, they are both concave up, and yet there can be intersections and thus critical points. So a very common mistake that anybody can do is this one. And another mistake is going for the 4-part T by T approach. So quite a wonderful and a brilliant question, no doubt, quite a very good quality question. And I really hope that this made you aware of different approaches that can be taken for a question when it is so difficult, and will help you in further problems when you're solving them. So thank you for sticking around till the end. Make sure you like the video, comment down below what more you would like to see next, share it with your friends, subscribe to the channel, and hit the bell icon to never miss an update. And I'll see you all in the next one.